How you going, everybody? So let's get started, eh? So who here has an ERP system? Raise your hands. Kind of lowish hands, but most people. And then who's actually using it to manage production? Oh, we got one, two. Alrighty. And I think most people are actually using the Swiss Army knife of production management, Excel. So why is that? Well, it's some of the software. The software is doing what it's supposed to do. It's the finite capacity scheduling model that it's based on that's really causing the problems. Just a little history, like Lilyworks has developed two ERP systems. One was Profit Key, currently owned by ECI, and the other one was Visual Manufacturing that was purchased by Infor back in the early 2000s. And both of these were based on the finite capacity scheduling model. So despite all the number of instances around the world, very few people are actually using the scheduling side of things. So the guys did a bit of a rethink about things. And if you really distill it down, it's the classic, we create a good plan, we go execute the plan. And when we look at creating the plan, typically what we're doing is we're prioritizing by want date. Whoever's needed first gets the priority. And then we load up our capacity. Now the capacity is loaded up using an algorithm. This is the finite capacity scheduling algorithm. And what it's doing, it's taking your estimated times to work out when jobs are going to start and finish, to then tell everybody what they should be working on. And when it does this, it does it in one of two ways. So one of the first ways is forward scheduling. So that simply takes the point in time where we are now and loads up the resources off into the future. The problem when we do it this way, we release too much work. So it's just like if we came here during peak hour, it takes a lot longer than if we came here during the middle of the night. It's the same distance, but the fact that there's so many cars on the road slow us down. And the opposite of forward scheduling is backward scheduling. So in this case, we've got our due date and we're loading up the resource backwards to consume that capacity. And the problem here is we're planning to finish on the want date. So if there's any variation in here, we're going to miss our target. So either way how it goes about creating this finite capacity scheduling model, we end up with our lovely Gantt chart that we're all quite used to. And then that's part of our plan, which also gives us our work to list. This is the magic plan that we then head out into production. We go, okay guys, we want you to execute this. And then quite often production will get this work to list, and it's very different to what's being discussed at the like a production meeting. Talking about different priorities than what's actually on this work to list. So people don't really believe it and don't follow it. And then when the performance ends up poor, not what you expected, is this the fault of the plan? Or is it production's fault for not following the plan? And do we just really need better predictions? Our plan here is a prediction of the future, what's supposed to happen and when. And maybe if we just get better at that, it's all going to be good. And if you think about it, the model's doing exactly what it's supposed to do. If we've given it bad data, it's no surprise that we're getting bad answers out of it. So we then go about trying to fix the data. So okay, well, we need more accuracy. We do time and motion studies. We try and be more precise so that we've got better estimates of how long an operation should take. Another thing we quite often do is we add more detail. Okay, so we've got to think about different things that could happen. Maybe we need people with skill sets or additional resources, whatever it is. We're just adding more detail to the mix. And the other thing we try and do is, prevent changes. We'll lock it down. No more changes. So this makes it easy. We just go off and do this. And then that all takes time. So quite often what happens is we just revert to Excel. We can tell it what we want it to do, give it to the guys, and we're off. And, just because we've always done it that way, it doesn't mean it's a good idea. So we really have a choice here. We can focus on perfecting our data, or we can change the model. We've got a choice. We could choose to, eliminate this variability, be very precise, very focused on all of our information. Or we can accept that there's going to be some variation. We can allow for it. And it's really just a question of then of how much variation are we going to expect. We can also choose to focus on our capacity utilization. The finite capacity scheduling model tries to maximize your utilization out there on the shop floor. And quite often what happens is you get too much cars on the road and it goes slower. It's sort of counterproductive. But we can also then instead just focus on executing our priorities, getting the most important things done. Also, we can then choose, do we want to protect the schedule, this prediction that it's come up with? Or do we want to protect the flow? If we're releasing work at the right time, we don't end up with too many cars on the road and all the traffic flows. That's quite often why on the freeways in the morning, we've got our lights, so not everyone tries to enter the freeway at once. So what we've really done here is we've flipped the model on its head. So instead of trying to plan and then execute, we're going to execute, then we're going to plan. And we've decoupled the relationship between the scheduling and the work to list. In a traditional approach, we had to run the schedule to work out what to work on. Here, they're disconnected. And there's always two answers. There's an execution answer, which is, what should I do right now? And then there's a planning answer, and then we're looking into the future, like what's coming up and being more proactive. So in terms of prioritization, in real time, we're prioritizing and executing. So we've got our highest priority tasks, and every resource across the shop floor is working on the most important thing. And it's independent of capacity. So, it doesn't matter if people turn up to work or don't. Well, not that they should be turning up to work, but, it's like, here's the things I need to get processed. These are the most important things I need to work on. And it's really, your priorities are your to-do list. We can all have our big to-do list in terms of, okay, here's what I need to get done. Whether I get them done or not is a totally different question. So if we break it down a little bit more into how we determine our priorities, we're using a threat level priority. There's a little bit going on here, and I'll just explain it. So we've got our due date, our target date. That's our promise to our customer. We want to protect that. We know there's going to be a variation, so we're allowing a buffer. We're giving some time protection to allow for that variation. The more uncertain we are, the bigger the buffer we need. The more certain, smaller buffer. And then over on the left, we've got our total work. This is just good enough estimates. Doesn't need to be super precise. The buffer's going to allow for any variation in the time, material not showing up, all that kind of jazz. And over here, this is the work that's been completed so far in the baseline of the execution plan. And this is right now, this point in time. So if we're to do this remaining work, which is half of operation 10, 20, and 30, and we would do them back to back, we're going to end up over here in this yellow zone. So our work remaining is it still has to be done, and our time protection is getting smaller. Yep, so we're looking at a ratio here of the work remaining to the time protection remaining. That ratio is calculated in real time and lets us know which jobs have the biggest threat of being late. That way the resources are focused on things that are likely to be late, not what's most convenient or what's needed first. Typically, jobs which are needed first would get a priority. And sometimes that can maybe make sense, but if you think about it, sometimes a job that has to go out for like heat treatment and all these external processes is in far more danger of being late than a job that's needed in the next week or two. So the threat level takes care of that because it's more about a risk approach rather than whoever's needed first. Another way to think of it too is like a hospital. They triage people. They don't go, okay, well, you got here first, you get the priority. It's whoever's got the most serious illness that gets the priority. And from that, we can see how everything's tracking across the whole shop floor or an entire department. And ideally what should be happening is the jobs are progressing nicely either side of this little green line here. But, if we're starting jobs too early, maybe the guys are not following the right list and maybe doing a bit of cherry picking on the nice jobs. What happens though here is we're wasting capacity making things we don't need And the price we pay for that is the things that we do need don't get completed. Then our lateness goes up, our customers get angry, and we don't want angry customers. And if you think about it, so whatever production works on is what gets produced. So, whether they're working on the right things or the wrong things, that's a different question, but whatever they're actually going to work on is what's going to get made. So to see the future, what we do is we simulate production executing those priorities off into the future. So if they're following the priorities and believing them, when we simulate you executing those priorities, this paints a much better picture here of what's likely to happen in production. It's not like this program does it one way and production's working something totally different. The two are almost a mirror image of them, like a twin, if you like. So we'll go back to our little execution plan that we saw earlier. Now, this will happen if we're able to do our operation 10, 20, 30 back to back. But obviously, we don't just have one job out there on the shop floor. We've got many. So whilst operation 10 could start now, there's two other higher priority jobs on that resource. So he's got to wait his turn. So he's not going to get a chance to be performed until over here. Then when he's finished, okay, the next guy is still busy. So he's going to have to wait a little bit and then he'll get his turn. And then finally, when he's done, we're going to be waiting a little bit again. And this guy's going to end up being a little bit late. So this isn't good. It's predicted to finish after the want date. Ideally, everything should be on the left-hand side, but at least we know that ahead of time. And because we don't want that, we can then start to do like a what if. So it could be, well, what would happen if we ran some overtime, we bought a machine, we said yes to this order that sales is working on, or we said no to that, we outsource things, we change it up in different ways. Then what we can do again is run a simulation with those changes. So we've got what would happen if we did nothing and what would happen if we do the change. Then we can compare the two in terms of like revenue or days late to work out, okay, what makes sense? What would be the best thing for us to do to eliminate that lateness? So really the choice here, with finite capacity scheduling or the dynamic production method. And I like this quote by Deming, which says that every system is perfectly designed to get the results that it does. So thanks, guys. That's it. I think we're kind of quite a bit ahead of time, so we can...
We love a quick and dirty power session sort after. So if anyone has any questions, now's a good time. No questions at all? That's okay, because Trevor's going to hang around. If you do have any questions, come and have a chat to him. If you want the process to be explained a little bit more detail or anything in particular, let him know. Otherwise, reach out to him at stand MS436. Take a scan of the barcode. Never late is better. It's all good. Please put your hands together for Trevor.
Thanks, guys.